All right, welcome everyone. This is our monthly Apple Core Dallas meeting once more. And this month, our guest is Dr. Gopal Gupta from the University of Texas, Dallas. He's computer science professor, previously the head of the department, correct? Yes. So he is going to be giving us his presentation on artificial intelligence. We started the SIG first. And so now we're going to be hearing from our distinguished expert on AI.
We'll try. Well, thank you so much for inviting me. And so you can see the title, right? So acknowledgement to. So I'll try to give you an overview of what AI is about. It's like maybe somewhat slightly different perspective than you might be used to from seeing the media and stuff. And thanks to all my sponsors who supported the research over the years. So talk a little bit about background and history of artificial intelligence, some failures. Okay, that's my email probably outside. And then of course everybody's talking about ChatGPT and large language models, right? And so we'll talk about that, and then limitations of LLMs and in general generative AI. And then, of course, the goal has been to achieve this artificial general intelligence, build machines that are at least as good as humans, if not better. And so I won't talk about actually, so you need reasoning as well. It's basically going to be my thesis, that you have to simulate human thinking as well. So let's talk about artificial intelligence. So in fact, the history is actually goes quite far. So as soon as computers are invented in late 1950s, then people are already trying to, how can we simulate intelligence on these computers? So the first program that was done, if you read an AI textbook, was by Checkers by a person named Samuel. So what is intelligence is the first question you probably want to ask, right? So how would you define intelligence? So in the interest of time. So one is that you could say, a being is intelligent if they have the ability to acquire or learn knowledge. If you automate this function, it's called machine learning, right? Which is the big term that you probably have heard enough of. But then once you learn, you also apply this knowledge. So that's another component of intelligence. We learn. So you might hear the sound of a siren going off and a tornado comes in Texas, right? You learn to recognize the sound of a siren. And then you also learn that, you should seek shelter because a tornado is coming. So now you're performing reasoning. So recognizing the sound of the siren is learning. You learned it, right? It's very hard to even explain why is that sound of a siren to someone. What does the sound of a siren sound like? Then of course you have vision, speech processing, speech generation, etc., etc. So of course, AI has been receiving a lot of attention, and you've heard the terms deep learning, machine learning, generative AI. So the question is, AI only machine learning or only deep learning? Well, that's obviously not the case, because reasoning is an important component of intelligent behavior. So if you look at the research landscape, so now the pendulum has swung the other way. It used to be, for the first 40, 50 years, AI was all about reasoning. How can we build rule-based systems, how we can reason intelligently, and so on. But today it's more, when people say AI, they really mean machine learning or deep learning or neural networks. So if you look at the research on these two strands of learning and reasoning, actually both started long time ago, even before 50. So I'll give a little bit of history. Well, what is machine learning, first of all? So the idea is that you're given some background knowledge, and you're given positive and negative examples of some concept. So you're shown pictures of birds, and so you're told these are objects that fly, but you're trying to recognize a bird. So you're given examples of objects that are birds and objects that may have similar properties as birds, but they are not birds. And then you sort of learn to distinguish between. So this is called a classification problem in machine learning. So you learn to classify. And much of our, you could say, learning is like that, although our learning is a little bit more sophisticated. So these machine learning systems work by you give them a huge amount of data, and they learn the association, you could say, between inputs and outputs. So you essentially automatically learn what is a bird. Then you have many types of learning algorithms. There are supervised learning, unsupervised learning, reinforcement. Okay, then what is automated reasoning? So if you automate reasoning, you get, of course, automated reasoning. It doesn't have a very obvious name. So here you're given pieces of information and you have to do what are called axioms. And if you might remember from your high school geometry, Euclid's axioms, for example, there are 5 Euclid's axioms of Euclid, and you can pretty much derive any theorem in plane geometry from those 5 axioms. So you're deducing new knowledge. So every new theorem is piece of new knowledge, like Pythagoras' theorem that you derive from those 5 axioms of Euclid. That's new knowledge. And so you have the axioms and you derive new conclusions. So for example, very simple example, you're told all humans are mortal, Socrates is a human, and then you can conclude that Socrates is a mortal. So that's automate, that's reasoning. Then if you automate this process, so machine learning has a long history. So techniques such as Bayesian network, Markov chains, least squares, and those of you who have a background in statistics or mathematics, or even social sciences, might be familiar with these terms. Perceptrons, neural networks that have played an important role in machine learning, they have been around for a while. So Bayes' theorem is from 1763. Bayes' theorem was actually discovered by Monk back then. Perceptrons, which are the basis of neural networks. Neural networks are all these, the technology behind image recognition, those types of things. So the technology actually was invented in 1957 itself, and then back propagation, which essentially corresponds to that neural networks basically have sort of a feedback loop. They're able to correct them, so they're able to learn again from 70s and 80s. In fact, the first international conference on machine learning was held in 1983. So it sounds like this is a recent technology, but it's been there for a long time. So what has changed? What changes the computing power, availability of lots of data, and you could say some advancement in algorithms. But mostly it is, the NVIDIA chips that you can see NVIDIA stock go up like insanely up, and the availability of data because of the web, right? All of us are doing social media, spending about 10 hours. I heard on TV the other day, on average, people are spending on their screens, and that's generating a lot of data, so you can learn from there. So today we have neural networks, deep learning, large language models, many innovative applications possible because of amount of data, right? So you want to get a computing power. Okay, what about large automated reasoning? That also has a very long history. So logic plays an important role in automated reasoning, and these techniques have even longer history. So Aristotle wanted to formalize thought processes back in 300 BC or something. There's a lot of work in ancient India on formalizing logic. But modern logic started in the 1850s with George Boole. You might have heard of Boolean algebra, or might have actually studied circuit design or something. Then you come across Boolean logic. That's from the 1850s, and then predicate logic and set theory, 1870s by, might not have heard of Gopal Gupta, but he's a German mathematician who discovered, invented, whatever you call it. And then there were people who were interested in automatically proving theorems, in theorems in geometry or whatever. And then today we have advanced theorem proving systems, logic-based programming languages, logic-based systems, rule-based systems. And in fact, foundation of much of traditional computing is in logic. So it was computer science. Now data has become more important. So you could say, well, there's a move towards data science. So computing and data are both important for. So what are machine learning systems? Maybe. Okay, so it's a little bit of intro. So what do machine learning systems do? So these are what you could call a universal function approximator. What does that mean? It basically means that if you're given a set of inputs and a set of corresponding outputs, the machine learning system will learn the function that maps an input to the corresponding output. Okay, so in our bird example, that process is called, the process of learning that function is called training. So we take our bird example, right? So you have a bunch of pictures of birds, bunch of pictures of other objects, and each one is labeled. So each picture is labeled with, because you have to give examples, whether it's a bird or not a bird. And then the machine learning system will try to learn a function based on, whatever pixel values or whatever is there in the components of the picture, so that it can map picture of a bird to bird and picture of a non-bird to the label. So basically, map the picture of a bird to yes, picture of a non-bird to no. So it basically will learn that function. Now, in the olden times, if you had to design a system that would recognize birds, you have to write a complicated algorithm that will analyze the pixels and maybe look at various colors, features, whatever, and try to recognize, oh, this is the shape of a bird. Very, very complicated. But today, this function can be learned. So you could say that, why would I program something when I can generate it or learn it, right, automatically? So this learn function is called a model. So these are the terms you will hear if you read a little bit about machine learning. So if people talk about machine learning model, what's a model? Is that function that we learn that now can be used for predicting. You give it a new picture of a bird, and this one, or non-bird, it will predict whether it's a bird or not. So we use the model to perform prediction. So example is passport control, right? So in fact, let me show you the picture first of today's. So this is passport control maybe 5 years ago, even or 3 years ago. You have a line and you enter the US or any country, right? You'll have a passport, whatever, immigration officer or border control officer, somebody sitting there. And this is what it looks like today. I don't know how many of you have done international travel recently. What do? You look into the camera, you scan your passport. And what is happening? The machine learning system that's sitting behind is matching your face picture with the picture on your passport. In fact, many airlines now do check in that. I don't know if sometimes when you board a flight, they will make you, as you enter the gate, they'll make you look into the camera, especially for international. And they actually already have your passport picture, so they're matching if it's the same passenger or not. Take it out from the hands of the human to recognize the person. So let's get back. So what happened here is that they gave it large number of examples so that our machine learning system could learn the function that tells if two faces are the same, right? So once you learn that function, now your job is easy. Okay, so rest you can imagine. So you could say that it's a dream of every lazy programmer who not have to write code. So now you don't have to write code, right? So, and that's what you see with ChatGPT and all these other things as well that we will come to. Okay, we'll skip the technical details here. We don't need those. So machine learning systems are very good at, these are the applications: image, video recognition, object detection, natural language processing, speech recognition, image captioning, music composition, robot control. So when it comes to recognizing patterns, maybe 50 faces at best or 100 faces. Machine probably can remember millions of faces. Right? So that's one way to look at it. So if we look at, again, history of AI, so there have been many successes, and but eventually many of those successes really did not. Some of them did not pan out at least. So you might remember from reading from the press. So the big one was Deep Blue that beat Kasparov, the chess playing program in the 90s. I don't know how you remember that. It beat Gary Kasparov, right? So this was actually based purely on reasoning. There was no machine, there was no learning involved. And remember, as humans, we learn and reason both. And then, of course, Watson, I don't know how many remember, won Jeopardy, right? 2012 or so. And that was the first one that actually made use of these learning as well. So I don't know if anyone watched the documentary part of Frontline or something on PBS.
Say it again.
There's a documentary on the Watson system on PBS that was aired maybe 10 years ago. So if you Google it, you'll find it. And it basically talks about how IBM started building it. And first they were only using reasoning, but it did not work out very well. Then they gave all question answer or answer question pairs. You know how Jeopardy is played, right? Given the answer, you have to come up with the question. So all answer question pairs were given since I started early 70s or something, right? Mid 70s when it started. And then it basically figured out through pattern matching as to essentially could learn where is the answer to be most likely or what's the most important part of the question. And then after that, it just started. And then there are these AlphaGo programs, so people thought that machines could beat chess. I mean, the world could beat humans in chess. They could beat the world's best chess player, like Deep Blue beat Gary Kasparov, but they won't be able to beat them in the game of Go, which is a Chinese game, bigger board and more complex in terms of number of possibilities. But then these machine learning systems managed to beat the world Go champion a few years ago. And now you have this program system called Alpha Zero, which actually plays itself and learns the moves, is able to pretty much beat any human. And then of course you have self-driving cars, and those are not there yet, right? They work, but so today, these machine learning data science is a pervasive technology, automated loan approval, college admission, recommendation systems of all sorts, tumor detection, face recognition, speech processing, all these things on Siri and Alexa, right? They're very good. Then when people leave you a message, your email system automatically recognizes it, translates it into text and emails it to you, right? How many of you have that, right? And they used to be horrible, even just 2-3 years ago, but they have improved that. Actually quite amazing. And of course, ChatGPT is a major, and then NL, natural language processing, where you automatically try to answer questions or understand stuff. And so that's where large language models have made a huge impact. GPT-3, GPT-4 BART. So ChatGPT is basically a manifestation of these GPT systems that were actually first designed by first one to come up was Google 4 years ago. And these have been around actually for many years, 3, 4, 5 years. When ChatGPT was created, it sort of captured people's imagination. And and we'll talk about how it works a little bit. It can write original prose for you, poetry, letter drafts, CVs, essays, and so on. Use for auto-completing sentences in your email, all kinds of things. So it sounds, great, and it's a great technology, don't get me wrong, because it can learn stuff and take a lot of burden off of you. And I was hearing some discussion where, so what can happen is that, for example, someone talked about sepsis. So as humans, we may see the impact of sepsis very late in the game. But a machine maybe can analyze, if you train it enough, if you keep taking pictures of somebody who eventually gets sepsis, but if you're smart enough, can keep taking pictures of whatever, skin or whatever it is, or data, whatever data is, keep saving it for the last 6 months. And then those who got sepsis, you give their data to a system and let it learn the association between who got sepsis and the parameters that were involved in the data. Then it might actually be able to detect, far ahead of when a human would be able to. So in the same way that if you look at pattern recognition and matching learning capabilities of other animals versus us. So for example, I was in Canada last week or week before that, and I heard that bears can smell 18 miles. 18 miles away they can smell. Or what is that animal that can smell? Yeah, camels can smell water miles and miles away. So we cannot smell water even from here, right? So these just few feet away. So these pattern recognition systems even nature can make them better. So you can see that if we somehow automate that, there are immense benefits to that. But there are many problems as well. You need huge amount of data. They are not explainable. So these systems are opaque. You cannot really explain. For example, the problem with these neural network system is that, say, you use them for approving a loan. And how does that system work? Basically, what has been done at a bank is that, the loan officer has been making decisions. So then, the data scientist came along and said, well, let's take the data for last 5 years of all the loan applications that came in. What are the inputs in the loan application? Maybe age, education level, income level, credit score, history of buying, selling, making payments, whatever. And then based on these features, as they are called, you try to correlate it with whether this person will pay off the loan or not. Right? So you try to learn that function, that model. And once you have that model, then you no longer need the loan officer. New person comes along, you feed the data, right? The inputs for that person to this model, and it will tell you, yes, give the loan, no, deny the loan, and so on. but it's a black box. It's not able to explain why that decision was taken, whereas a loan officer could. So that's a huge problem with these machine learning systems. If it says, suppose you put your passport and you look into the camera and it said, well, no, these two people are different, then it will not be able to explain to you why these two people are different. Now you could argue that even for us it will be very hard. They're computationally expensive. We humans use only 12 watts of power. These machines use megawatts and megawatts of power. They cannot do reasoning, and there are all sorts of things. And there are examples that you might already have seen. For example, self-driving cars. You will never be confused that this is not a stop sign, right? But they put these stickers, and self-driving cars could not tell it's a stop sign. The more interesting example is where you add some noise to the picture. So this was classified as a panda, and then add some noise, and then it says now it's a gibbon. But that's okay. It's just you got mistaken, in identifying an animal. But a bigger problem is if you find bus and not right? So, and again, these are very well-known examples if you read the picture. And then, of course, autonomous vehicles. I won't go into them. I mean, they have been around for a while, but you could say they haven't heard delivered. And this quote here from 2018. Oh yeah, he promised. I mean, Elon Musk said we'll have complete autonomy by 2018. And this statement is few months old in a court case. A broken or expired promises is a failure, not fraud. Is the quote from the lawyers. And there are many. So essentially, there are limitations to machine learning to this version of AI. So let's talk a little bit about ChatGPT, right? So it released November 30, 2022, extension of GPT-3. And it's been fine-tuned through this. So the way it works is, well, we'll talk about that in a second. So it reached million users in 5 days, probably the most viral, piece of anything ever. It generates text, poems, and many of you, I'm sure, have used it. So you can say, well, write me a poem about a father holding a newborn child. And this is what it generated, actually. So I generated this several weeks ago. And you can see it did a pretty good job. The arms, keyboards, a miracle, a tiny lives of US of Europe, etc., etc. And then there are many other systems that I heard in the discussion. You're talking about the DALL-E system that will produce art from natural language prompts, or Adobe is doing now. So you can say, well, two cats playing chess, and see what you get. Something like that. And then of course, since then there are many. You can generate music, you can generate a speech to give at somebody's graduation, or at a party, or nice poem for your wife or husband on the anniversary, and so on. So ChatGPT can produce text that reads like human written text, but how does it do it? So what it does is, given an incomplete sentence, LLMs try to predict the next word that would reasonably fit after those words. Somebody's not mute or something.
Yeah, it sounds like somebody's not.
So given an incomplete sentence, these large language models, that's the general term for this ChatGPT technology, try to predict the next word that would reasonably fit.
They're moving something on their desk.
Yeah, and what's the reasonable fit? What someone may write after looking at billions of sentences. So let's take an example. So let's take the sentence. The best thing about AI is its ability to blank. What word will come after that? That ability to. So there are many possibilities. You might say the best thing about AI is the ability to learn, predict, make, understand, do something, right? There are many possible words. So what these large language models do is they analyze billions or hundreds of millions of documents, and they kind of create what's called a probability distribution as to, given, let's say, these 5 words about AI is its ability to, what word can come after that based on what I see is out there. And there are many possibilities. I'll say, well, I see learn 4.5% of the time, predict 3.5%. And then what it does is that it picks the most probable one and fits it there. So you see what is going on. So in some sense, it's a very simple technology. It has ingested millions, hundreds of millions of documents and sentences. And then as it generates words, it tries to find the next word based on what it has seen all over. Right? And all that is possible because the computing technology is advanced. You could say the algorithms have advanced as well, and so on. But it does not pick the most probable word. It may not pick the highest probability word. It sometimes picks the second one, the third one, and that's why it appears human-like. Because we humans don't do that. Right? When we say the same thing, we'll always change the words, right? Or we're not able to say the same thing exactly the same way the second time if you ask me to repeat it. Right? We make it different. And that's what is happening, that we're basically coming up with other words. And so it tries to, you would say, mimic that. So it picks and that's controlled by parameters. You can set a parameter for temperature of these systems. So, okay, so what is really happening is that, again, I'll summarize this. I'm not going into the details. So what is really happening? So what happens in AI? So how does AI work? So in AI, most of the time it involves some kind of search. So for example, when you are playing a puzzle, right, like Sudoku or something, then suppose you were to write a program for playing Sudoku, what will you have to do? You have to generate gazillions of possibilities, moves that are possible, right? Keep making possible moves. There'll be gazillions of possible paths that you could take, right? Given a specific puzzle. And then some of them will not give you the right answer, some of them will give you the correct answer, and so on. And your goal, your algorithms, the AI algorithm's goal is to find the path that will solve the puzzle, right? So most of the time, AI involves search. And you could say even intelligence involves search, right? When you have to figure out a solution, there are many possibilities, and I have to find the one that meets my goals, right? Or, for example, planning. So planning, you're in an initial state, you have to reach a final state, and at every step, at every point, there are many possibilities, possible paths you could take, and you have to find sort of the right path that will get you to like going through a maze or something. So most AI systems are based on guessing and then checking. So you say, okay, let's go down this path for solving Sudoku. Let's make these series of guesses. At some point, it doesn't work. You say, oh, I have to backtrack. I have to go back and change the path and so on. Right? That can take a long time. So if you were to write a program for generating novels, for example, or 20-page essays, right? You could potentially do that. There are 10,000 words, let's say, in the English dictionary. I could generate every possible novel, assuming that every novel is 200 pages, right? You can imagine that, right? That I could generate but it takes me trillions of years. So what the large language models do, they say, well, you have to generate, you generate your novel or story or whatever, word by word. But the next word that you generate should be the correct one. How do I ensure it is the correct one? When you look at hundreds of millions of documents, you use that probability distribution, basically. You say, okay, what have other people done? What have other people, what is the next word that other people have written if I look at, hundreds of millions of documents? And so now you see, you don't have to backtrack. So you keep generating text. But this text is generated under certain constraints. You might say, and that's why you hear about prompt engineering. What path it will take will be based on how much information you give to the ChatGPT system, right? So if you simply ask the ChatGPT system, recommend me a restaurant, it will say, well, right next to the library is a McDonald's, why don't you go there, right? But if you said, oh, it's my 20th anniversary and I am looking for a romantic place and my spouse likes Japanese food, then it might give you and I'm willing to spend money, then it will give you a much better answer. So this prompting, and what that is doing is guiding your selection of words as you move along that path. And it can actually give you wrong answers too. because all it is doing is guessing the next word, and if it guesses the next word wrong, so that's all the thing about searching. Okay, so generative AI, as the general terminology is called. So how does DALL-E, the picture generator, works? It is getting the next pixel, the next pixel, the next pixel, the next pixel, based on gazillions of paintings that it has seen, pictures it has seen. Right. So quite amazing that it works, actually. I mean, it is quite amazing what it can generate. I mean, it's really wonderful. So, and that whole field is called generative AI, where you're basically generating stuff based on examples that you have seen. You're generating similar things to what you have seen. But what you're generating is constrained, you provide the constraints, so to speak, as to what you want to, like you said, show me a picture of two cats playing chess, and then it generated that for you. So it's great for creative tasks, not so good for logical reasoning and mathematical reasoning. That's the problem. And since it's working by generating the next word, suppose P is the probability that the next word will take us out of the current path. Then if you go down n times, you guess n words, then 1 minus P to the power n is the probability that you are on course, you are on the right string, generating the right string. So even if this P is 0.001, right, that the probability that you will go off course in guessing your next word, very small, 1 minus P to the power n can quickly become basically give you wrong answers. Okay, so so positive points about using these large language models, ChatGPT. Essentially, it mimics common structures and use of language. So as we heard, answers and dialogues are generated from statistical word distribution. It generates sentences that follow our prompt, and can be fluent, topical, coherent sounding responses. But there are cons as well, lacks meaning, or it doesn't really understand what it is generating, has no clue, lacks grounding in specific evidence, cannot do logical reasoning, and it can actually fabricate information. So if you ask it for directions from Dallas to Boston, which I did maybe several weeks ago, then it took me to North Carolina. Then from there, it took me to South Carolina. And then it did put me eventually on 95. So it'll generate something that looks like, directions, but the roads may not connect. Because remember, it's doing pattern matching, it's generating the next word. So I suspect what is happening is that more people in North Carolina go to South Carolina than go to North. So when it looks at those documents or sentences, it says, oh, the probability, basically the probability distribution takes it to South Carolina. So you see what is happening. And the way the technology works, no amount of advancement, unless you change the technology, is going to give you the right answer. So it's great for creative tasks, but not so for. So if you use it for anything, make sure you check it, you verify. Don't just trust it blindly. And in fact, if you say, give me a reference for something, you say generate how you would, for example, fix something in some machine, and then you ask it, well, it gives you some answer, and you say, give me a reference for this. Then it can fabricate that reference, which will look like a real reference. It will use the authors who have written papers in that area. It will fabricate a title, but the paper was never written. It just fabricated it. So lack of trust, again, transparency, it's not able to explain, and it's not self-aware. So again, great for poetry, writing, drafting letters, getting information that's out there, but don't trust it. For factual stuff, if this factual stuff is present enough, then it will be correct, but it can be wrong as well. Okay, so if you ask it, I think they keep fixing it. So, who got the Nobel Prize in 1650, for example? But who got the Nobel Prize in 1650? Anyone knows?
What year?
Nobel Prize in 1650. It didn't exist, right? It didn't exist. It's only awarded since 1901 or whenever. But ChatGPT will happily tell you Isaac Newton got it. So those are the type of mistakes it will make. If you ask what is 2 plus 2, it will tell you 4, of course. But if enough people had said 5 on the internet, it will say it's 5. Okay, so now you see. So it can be biased, it can discriminate, it can hallucinate, as they call it, which means manufacture disinformation. So because there is no thinking going on, absolute pattern matching. So we are purely in the realm of learning, pattern matching, no reasoning. And as I said, AI is not only pattern matching and learning, it's also reasoning. So it's great as an aid to humans, but just keep it as an aid. Don't, if you're building customer-facing tools, anyone, I would not recommend it because it can give wrong information, go crazy. So, for example, there have been instances where it tell people go kill yourself or something like that. So you can think of ChatGPT as a precocious, and they use the term stochastic parrot, 5-year-old or maybe 8-year-old who's heard enough, heard enough adult conversations, doesn't understand really what the adults are saying, but you can reproduce what they said and combine them and give answers. So I would say it's okay not to pour cold water on your enthusiasm. It's a great tool, use it. But I would say that ChatGPT is where autonomous driving was 10 years ago. In 10 years, we'll say, we'll understand the limitations as the general public and say, oh yeah, you can do this, cannot do this, so on. So use it, it's a wonderful tool, but not for critical things. Okay, here's an example. 2 children, Chloe and Alexander, went for a walk. They both saw a dog and a tree. Alexander also saw a cat and pointed out to Chloe. She went to pet the cat. Who saw the cat first? So this is the answer. Both Chloe and Alexander saw the cat at the same time, since Alexander pointed out. You see, he got confused because Alexander who saw the cat, right? But since they said both saw a dog and a tree, it really cannot tell that after the word, in the answer, whether it should be, you cannot distinguish between dog, tree, and cat. They're all the same, as good as, one is as good as the other. So it basically comes up and says, concludes that, or should say conclude, it basically so that both of them see it at the same time. Another one is, went to a party, arrived before John. So in these kind of reasoning problems, it will not do well. David arrived before, so another few minutes I'll finish. Yeah. David arrived after Joe, Joe arrived before me, John arrived after David. Who arrived first? First, it's impossible to determine who arrived first based on, because it cannot reason. Even for us, we have to take a piece of paper and have to write down, right? Then we will reason. But since it's only doing pattern matching, unless somebody had exactly solved this problem somewhere and it found it somewhere and it's already ingested it, then it will be able to solve it, otherwise not. And what are some possible solutions? It depends on what problems you're referring to. Like, can Joe, I, David, John be a solution? It says yes. And then this can I, Joe, David, John be a solution? It says yes again, and so on. So you can, what gender will the first female president of the United States be? It's female. But it's not possible to predict the gender. I think the first female president of the United States has a long history of recognizing and protecting the rights of individuals, blah, blah. So basically, can large language models give us artificial general intelligence, be as good as humans? So my goal, at least in my lab, our goal is to build systems that can emulate an unerring human. I think that's the best we can hope for. So all these things you hear about singularity and AI taking over, I think people probably just say that to get the press, I believe. But it's okay, they're free to say whatever they want to say. So the large language models lack awareness. They don't know what they know and don't know. They really have no idea. Because all it is doing is pattern matching. Everything it says is 100% correct. And we work with incomplete information, right? We don't need to know all the information, but we're able to still make decisions. All these machine learning technology won't be able to do it. So last slide, look at nature. So basically sensing is like pattern recognition, right? When we see our senses, right, we're recognizing patterns. So animals can see objects, recognize sound, recognize touch, smell, and then we act on them. So I think I gave you the examples that nature has done a good job of creating such systems, like pattern recognition systems. So dogs, for example, have a far better sense of smell than humans, and camels can sense water, right? And bears can smell much better than eagles, have better eyesight, and so on. So nature has wired the animal brain for pattern recognition induced action, right? So we recognize the pattern, then we take action. So that's sort of through evolution, this behavior has been wired in us, or instinct as we call it. Right? So instinctive behavior is really pattern recognition based behavior. A bee will instinctively sting. So with respect to pattern recognition, we have similar capability, say, with respect to senses. Now, we are much better at our language processing capabilities, of course, are much higher. But do animals have reasoning capabilities? As we move up the evolutionary chain, capability to reason improves, right? So, and we are the masters of reasoning, best in the animal kingdom. So, if you really want to build artificial general intelligent machines that are as good as, we need both learning and reasoning. You cannot do without reasoning. Learning is great; it will get you so far, but it won't, get us to this goal that many have of building these advanced. So, okay, so I think that's pretty much it. A lot more details than you care for. Okay, so there's a takeaway. AI technologies, both learning and reasoning, have been developed through research over the past 50 years. Machine learning and deep learning technologies have become prominent as more data and computing power has become available to make them extremely useful. Both technologies have tremendous potential. However, we don't have human-like intelligence yet. And ChatGPT comes close, but I showed you the limitation. I mean, it's a phenomenal tool, wonderful tool. So the road forward really is to combine machine learning and automated reasoning to produce systems. Now, once you bring in reasoning, then reasoning is actually very hard. It's right. Most of us don't like to think, right? Don't like to reason. Nobody wants to reason, right? Think. And when you bring it in, when you automate it, then you still face many challenges. So automating human thinking or human reasoning is extremely hard. So the bottleneck of learning immense amount of common sense knowledge that we have cannot be avoided. So the challenge is how to learn automatically. Right? We'd like to learn learn this common sense knowledge automatically is what I mean, right? All these things that we learn that, if I drop this, it will fall and it will break. If the ground was hard, it will break, but if it is carpeted, it won't. Very likely won't, right? So all these things we have learned through experience. How do you automate that? Right? How do you automate that? Now, ChatGPT has all this knowledge. It may be able to tell you, sometimes it may be able to tell you the correct answer, sometimes it may not, but you cannot rely on it. But we can rely on reasoning. Okay, so I think, so then a little bit about, advertising for UTD. So we run the Center for Applied AI and Machine Learning, with industry-facing center, where we actually do projects in AI and machine learning for companies. There are a whole bunch of companies that we have helped. So, if you have an AI problem related to AI that you cannot solve, need researchers, we can help. We also have a master's degree program in a part-time format where you take classes on Friday evening and Saturday. And this degree is basically half software engineering and half AI. So if someone wants to learn AI, all these machine learning, big data, cloud computing, artificial intelligence, natural language processing, we basically have a 2-year degree program that one can do on a part-time basis. And then if you have children, grandchildren who are in K-12, we actually run camps and during the summer, teaching them AI and coding and all kinds of things.
Could I go to the camp?
Sorry?
Could I go to the camp?
Could you go to the
Am I allowed
camp?
to go to your camp at the university?
You have to be a K-12 student.
Huh?
But that's a good point to maybe hold a camp for, now that there is so much interest, hold a camp for adults. Yeah, sure.
I could have fun teaching there. Maybe.
Oh, you would teach there? Okay. Well, most of the time what they do is, so unless you want to volunteer, it's the grad students who teach. So it costs next to nothing for for the camp. I mean, it's basically mostly volunteer. If you want to volunteer, yeah, absolutely.
What is it called again?
It's k12.utdallas.edu, the website.
K-12?
k12.utdallas.edu will get you there. I should bring QR codes. k12.utdallas.edu. Yes, yeah.
I've also heard that once you reach 65, that courses in UTD are
Correct.
free.
That is true.
Is that all of this as well? All your AI courses?
So yes, so I think all courses become available after 65 for free. Now, there are some, yeah, so some restrictions. I think some, for example, in the engineering school, especially in computer science, the courses are in so much demand that we have the right to say no. And I used to be department head and I've come across this, but the number of people coming is so small that we're happy to let people in. So as long as the numbers are small, because otherwise, we don't have large enough room, and room capacity is 70, and there are 70 people who want to take the course who are over 65 just out of interest, and we can't teach our students. So there is some hoop to jump through, but it's